Draw a line of fit for the data given in the table, and then write the equation of the line in slope-intercept form. Then use the equation to predict the number of staph infections at a hospital 16 months after the initial outbreak. So in this problem, we've been given a few things to do. But the first thing we've been asked to do is to draw a line of fit for the data we've been given. Taking a look at the table, we have months, which is representing X. That's the number of months after the initial outbreak. And then we have the number of infections, which is representing Y. Now, if we take these X, Y ordered pairs and plot them, we get a scatter plot that looks like this. Again, the number of months is on the X-axis, and the number of infections is on the Y-axis. Now, the first thing we've been asked to do is to draw a line of fit for this data. Remember, a line of fit is a line that fits closely to the scatter plot of data that we've been given. Here, we could draw our line of fit as this line right here. If we look, we can see that this line is pretty close to all of the points on our scatter plot. So it's a pretty good line of fit. Now that we have this line of fit, we need to work on making an equation for this line and putting it in slope-intercept form. Well, to write an equation of a line, we need a slope. And to find a slope, we first need to pick 2 points from the line. So, looking at our line of fit, let's identify 2 points that we know are on the line. Let's pick this point right here. This point is the point 6, 14. We can use that as one of our points to help us find the slope. Then, let's also use this point right here. This is the point 14, 10. We can use both of these points to help us find the slope of this line. Now in step number 3, we focus on finding the slope. Remember, slope is written as m, or we could write that as the change in y over the change in x. Or still, we could rewrite it as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. These x's and y's are x and y coordinates from our 2 ordered pairs that we just chose from our line. So let's identify those x's and y's. Taking a look at this ordered pair, let's have the x coordinate be labeled x sub 1. That means that this y coordinate must be y sub 1. Then here in our other ordered pair, we will have x sub 2 and y sub 2. Perfect. Now we need to take those values and plug them in for our formula for slope. Y sub 2 is 10, and y sub 1 is 14. X sub 2 is 14, and x sub 1 is 6. Then we simplify to find our slope. 10 minus 14 is negative 4, and 14 minus 6 is 8. Negative 4 over 8 is negative 1/2, which we could rewrite as negative 0.5. So now we have the slope of our line. Now we need to make an equation for our line of fit in slope-intercept form. Well, we can do this a number of different ways. But here, let's actually write an equation for our line of fit in a different form. Let's start by writing an equation in point-slope form. Then we can convert it to slope-intercept form. Point-slope form is y minus y sub 1 equals m times x minus x sub 1. Here, m is the slope that we just found. And x sub 1 and y sub 1 are coordinates from an ordered pair that comes from our line of fit. So, we could pick any point that falls on our line of fit. But here, let's use this point, 6, 14, since our coordinates are already labeled x sub 1 and y sub 1. So we plug those in and we have y minus 14 is equal to our slope, negative 0.5, times x minus 6. Perfect! This is the equation of our line of fit in point-slope form. But remember, we want our equation in slope-intercept form. So that means we need to convert this equation to slope-intercept form. To do that, we need to take the equation and solve it for y. So we need to take our slope and distribute it into these parentheses. We get y minus 14 equals negative 0.5x plus 3. Then to get y fully by itself, we add 14 to both sides of our equation. And we get that y is equal to negative 0.5x plus 17. This is the equation of our line of fit in slope-intercept form. Great! Now there's one more thing left to do. We want to take this equation and use it to predict the number of staph infections at this hospital 16 months after the initial outbreak. Well, remember, months is representing x. That is the x value in this equation. And we want to find the number of staph infections, y. So in order to perform this prediction, we need to take months, the 16 months, and plug that in for x into this equation. Then solve for y to get our prediction. We have y equals negative 0.5 times x, which we want to be 16 months plus 17. Solving for y, we get that y is equal to 9. So, we are predicting that there will be 9 staph infections 16 months after the initial hospital outbreak. And if we take a look at our line of fit, we plot the point 16, 9. And we can see that it falls on our line of fit. So here, we used the data from this table and this scatter plot to create a line of fit. Then we wrote an equation for that line of fit in slope-intercept form. Then we predicted that there will be 9 staph infections at this hospital 16 months after the outbreak.